right, our objectives today, we're going to learn how to calculate the probability of independent and dependent events. We're going to learn how to use a tree diagram, which we talked about last time, in calculating probability. And we're also going to calculate probability from sampling with and without replacement. First, we have an opening question. So, if box X contains 2 blue and 2 green marbles, and box Y contains 1 white and 3 red marbles, a marble is randomly selected from each box. Determine the probability of getting a blue marble from X and a red marble from Y. Take a second and use your tools that you learned from last lesson to try to see if you guys get the right answer. Okay? So, in this situation, I would try to draw either a, since there's 2 different types of events, I want to see where my 2 different events intersect. So I would actually draw a 2-dimensional grid where I have box X, and I have box Y. Box Y contains 1 white and 3 red marbles. Now box X contains 2 blues and 2 green marbles. Now, in order to find out where I'm actually looking for, I want to determine the probability of when I can get a blue marble from X and a red marble from Y. So, I have a blue marble from X in all of these categories, all of these sections. But I get a red marble from Y in every one of these sections. And as you can see, where I cross over there, I have 6 different spots. I have 6 different intersections of my blue and red boxes, or red marbles that I've selected from my boxes, where I not only grab a blue marble from the X, but a red marble from the Y. So I have 6 over how many outcomes I've had. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 outcomes. So I have 6 over 16 outcomes, which would give me my percent. And 6 over 16 ends up being about 0.375. So about 37.5%. All right? Now this is a compound event. Not only do we want one thing to happen, but we wanted also another thing to happen. So that's where we have the word and. You learned a little bit about that last time, the word and or. And means we want both things to happen. So we have to have the blue marble picked and the red marble picked. Okay, so compound events. A and B are both events which occur, which the occurrence of each one does not affect the occurrence of the other. Okay, so I have A and B. So they're compound events, and that's where we have an independent, we sometimes will have an independent event. The events are independent if the occurrence of each of them does not affect the probability of another. So this could be, I roll a dice, I want to see if I roll a dice and I get a 3, and I flip a coin and I land heads. It doesn't matter if I get a 4 or 3 or 5, that does not affect my flipping of my coin. I'll always be, it won't affect my coin, how I roll my dice. But maybe drawing a card from a deck and keeping it keeping that card out will affect my second drawing of that from my second card drawing from that deck. So that's where we're going to be a little bit, we're going to show that there's a little bit of difference between independent and dependent events. So that first problem up that we just did for the opener, are the events in the opening, was that independent or dependent? Well, they were two different boxes. One did not affect the other, so they are independent events. They are, one will not affect the other's outcome. I could have selected a blue marble and still selected a white, and it would not have mattered because selecting blue from box A does not affect selecting white or red from box Y. So, just like I was saying, a coin and a die are tossed simultaneously. Determine the probability of getting a heads and a 3 with using a grid, without using a grid. Okay? So we have to be able to see that, okay, we're going to have two different types of outcomes here for a coin. We could either have a heads or we have a tails. So there's going to be a 1/2 percent chance that we are actually going to get our outcome that we want, because we want the probability of getting a heads. Multiply by, and we have to get a 3, okay? So there's 6 numbers in on a dice, and there's only 1 3, so we have a 1 out of 6 chance of getting a 3. So I multiply across, and I actually have a 1/12 chance that I'll flip aheads, and I'll have the probability of getting a 3. Now, if you have trouble seeing how I got that, so I have the probability of A times the probability of B equals my probability of both of them, okay? So the probability of A and B, okay? So the probability of A times the probability of B will give you the probability of A and B. So that's how I'm going to be able to figure out, well, if I want to flip a coin and get a tails but get all even numbers or get all odd numbers. Okay, next is dependent events. So the opposite of independent is dependent. So having dependent events means that the event of which of the occurrence of one of the events does affect the occurrence of the other. Okay, so like problem above. So suppose a hat contains 5 red and 3 blue tickets. One ticket is randomly chosen. Its color is noted, and then it is put aside. So then a second ticket is randomly selected. What is the chance that it is a red? Okay, so it's kind of hard to see here, but that we can't really tell right away that what our second ticket, the probability of our second ticket being a red, because of our first ticket, we do not know what was drawn. We don't know if it was a blue, we don't know if it was a red. So let's say that if it was a red one drawn, I would have had 4 reds left, and I would still have had 3 blues. So therefore, 4 out of 7 chance, I would have drawn a red on the second try. However, if a blue was selected on the first drawing, I would have had 5 reds left and only 2 blues left, which would have meant that I would have had 5 out of 7 chance to get a red. Therefore, we don't actually know what our percentage of chance of getting this. So we would have to, so it's labeled as a dependent event. So if A and B are dependent events, then A and B is equal to A, probability of A times the probability of B given that A has occurred. All right? So the probability of A times the probability of B given that A has occurred. So we'll have an example. We'll see this. All right? So a box contains 4 red and 2 yellow tickets. 2 tickets are randomly selected from the box. From box 1 by 1. Okay, the box contains 4 red and 2 yellow tickets. 2 tickets are randomly selected from the box, 1 by 1, without replacement. Find the probability that both are red, and then find the probability that the first is red and then the second is yellow. All right? So we're going to find the probability of that both are red, and then the probability that the first is red and the second is yellow. Okay? So the probability that both are red. Okay. Okay, so first we have 6 tickets there. So the probability of A times the probability of B when A has occurred. Okay? So the probability of A, which is a 4 out of 6 chance that red was selected the first time, times, now we have said that red had to be selected the first time, so what's the probability, since that red was selected the first time, that it will be selected again? It's a 3 out of 5 chance, because one of those red tickets was taken away, and so 1 ticket was taken away from our total. So then we just multiply across, and we get 12 over 30, which can be reduced down to 2/5. Okay? So we have a 2/5 or 40% chance of selecting a red ticket both times. Now, B, I want to select a red ticket the first time, but then a yellow ticket my second time. So at the probability of A, my red ticket selected the first time, times the probability of B given A. Okay? So the probability of A is still my 4/6 times the probability of B. Now I've subtracted 1 of my tickets, so I have 5, but I still have those 2 yellow tickets from before. So I'm still keeping the 2, unlike in my first problem where I actually subtracted 1 of my yellow or 1 of my red tickets. So again, multiply across just fractions. I have 8 over 30, and that can be reduced down to 4/15. All right. It's a little bit harder to see that how those intertwine, especially since that they are dependent of each other. You have to understand how we're going to be getting from one event to another. Now another problem. Hat contains tickets with the numbers 1, 2, 3, all the way up to 20 printed on them. If 3 tickets are drawn from a hat without replacement, so we're drawing them and we're keeping them out, determine the probability that all are prime numbers. Okay? So we're selecting 3 tickets here. All right, first we have to figure out what our prime numbers are. All right? Our prime numbers between 1 and 20 are 2, 3, 5, 7, 11, 13, 17, and 19. All right? Now that you can see that I have 8 prime numbers given, you guys can try this problem out, see how you do, all right, and we'll go over it. All right, so if I have 8, all right, I have 3 probabilities. I have the probability of A times the probability of B given A times the probability of C, probability of C given A and B. All right. So I have 8 over 20 because there's 8. I have 8 primes in my 20 printed numbers. Multiplied by, well, I took away a prime, but I also took away a card. So I have only 7 primes left and 19 cards. And now I've taken away another one. So I have 6 over 18. Okay? So now I just multiply across. And I end up with 3,840 all over 8 times 7, which is 56, times 6, which is 336, which is about equal to 0.04 or 4%. All right? So not really great odds. You get worse odds when you're going along because you have to have every single probability or every single event occur. All right? Now we'll move on to our second to last topic, our tree diagram. Okay? So being able to see how one event occurs to another, kind of like how we did the other day with our tree diagram. So here's our beginning event. So consider an archer fires two archers fire simultaneously at a target. So one has the probability of hitting the target at 0.75%, and the other has the probability of hitting at 0.45%. All right, so we want to find the probability of hits and misses. Okay, so the probability of the first one hitting is 3/4, and then the probability of missing is 1/4. However, then we have to go off of each hit and miss off of the first ones. So we have probabilities of hitting and missing off of both the hits and miss. Okay? So in order to find out what our possible outcomes are, we have to multiply across. So we have 3/4 multiplied with 4/5 to come up with our outcome of both hits, which would be 12 over 20. Now, if I wanted to find out how if the first one could hit and the second one would miss, I'd multiply the 3/4 by the 1/5, and I would get the 3/20. So, knowing that I can be able to figure out the probability of the hits and misses by on the marks of the tree, by being able to see on the branches that I could put the probability there and just multiply across. Also, noticing that there's going to be 4 different outcomes, since I have 2 different outcomes on my first event, and then off of each of those events, I can have 2 different outcomes. So noticing that I'll have 4 different outcomes, so I'll have 4 different probabilities. But all those probabilities added up will be 1. And the probabilities of each outcome is obtained by multiplying the probabilities across on the branches. That's what we're just going over. On the bottom one, if I have 1/4, I want to find both misses. I have 1/4 times 1/5 equals 1/20. So the probability of both of them missing is 1/20. All right, so here's an example. 2 boxes, each containing 6 plants that are not yet flowering. Box A contains 2 plants that will have purple flowers and 4 plants that will have white flowers. Box B contains 5 plants that will have purple flowers and 1 plant that will have white flowers. So A box is selected by tossing a coin, and 1 plant is removed at random from it. Determine the probability that it will have purple flowers. All right. So use your tree diagrams and be able to maybe try to find out if you can see if it will have a purple flower or not. All right, so our first chance, we just go over. We are going to either have a heads or a tails on this toss. Okay? I know it sounds weird dealing coins with the boxes, but it's either going to be a heads or it's going to be a heads or a tails. You have a 50-50 chance of going to either box. So I have a 1/2 chance of choosing box A or choosing box B. Then box A has four white flowers and 2 purple flowers. Okay, so 2 purple flowers of 6, so there's a 2/6 chance of choosing purple, and then there's a 4/6 chance of choosing white. Box B has 5 purple flowers, so there's a 5/6 chance, and there's a 1/6 chance of choosing a white. So these are the outcomes we want. We want this outcome and we want this outcome. We want to have a purple flower. So we have to multiply our different going across to get to those outcomes. All right. So there's a chance of getting a purple flower. 1/2 times 2/6. Multiply across, I get 2/12. So there's a or 1/6. I have a 1/6 chance of choosing that those purple flowers in that box. But over here I have a 1/2 times 5/6, which is equal to 5/12. All right. So if I can add those two together, I have 2/12 plus 5/12 is equal to 7/12. I have a 7/12 chance of choosing a purple flower. A little bit more than 50%. And you can I'm going to maybe guess that because of the purple flower having more a greater influence in box B than the white flower had in box A. So being able to multiply across, going from one box to another, multiplying from the branches, and then noticing that both outcomes, we want to look at both outcomes. So we could have outcomes from A and B, so we add them together so we get 7/12. All right, then we're going to talk, we've already talked a little bit about sampling with and without replacement. So the sampling, think of it almost as mostly with a deck of cards. If I want to draw out cards, you're drawing, you want to look for a king. So there's 4 kings in the deck. I have a 4 out of 52, 4/52 chance of drawing a king. Now, if I put that card back, I have again a 4/52 chance of drawing that king. But if after I draw that first card, I keep that card out, if it wasn't a king, now I have a 4 out of 51. Now, if it was a king, I have a 3 out of 51. So just knowing that without replacement means that I'm not going to put that sample back. But with replacement means I'm going to put it back. So suppose that we have a large group of objects, and then if we select one of the objects at random and inspect it for particular features, and this produces is known as sampling. Okay, so sampling, that's a lot done with DNR and with sampling of wildlife. If this object is put back into the group before another one is chosen, we call that sampling with replacement. So like I was saying with the deck of cards. And if the object is put aside, we call that sampling without replacement because we did not replace it before we took another one. All right, so consider a box containing 3 red and 2 blue and one yellow marble. What's the probability of getting 2 reds if replacing them? If replacement occurs? So I want 2 reds if replacement occurs. So the first chance of getting a red, I have 6 marbles altogether, and I have 3 red ones. Okay, so that's my probability of A. I pulled a red one, all right? But I want 2 reds. So after I drew that first red one, I put that right back. And now I'm going to draw another one. So not only did I keep my 6 marbles in there, but I kept my 3 reds in there. So instead of going down to 2 reds and then 5 marbles altogether. So I'll multiply plus, I got 9 over 36. Nine over 36, which is about 1/4. Okay, so about 25%. Now, getting 2 reds if replacement does not occur, I'm going to instead have 3/6 times 2/5, which is where I'm going to not only lose a marble, but I'm going to lose one of my reds. So I have 6 over 30, which is about 1/5, which is 1/5, and about 20%. So why don't you guys try those last 2 ones, and we can come up with the answers. All right, so getting 2 different colors if replacement occurs. So I want 1 color. All right, so this is a little bit more difficult. I want 1 color, so I could have a 3 over 6, so I drew red, and then I could get a blue, so 2 over 6. But that's not the only event that could happen like that. I have a 3 over 6 times a 1 over 6. And then I have that third event, I have a 2 over 6 times, I have a 2 over 6, which was drawing my first blue one, times a 3 over 6 was my red, plus a 2 over 6 drawing blue again, and then times a 1 over 6, which is my yellow, plus a 1 over 6, so drawing yellow first, times a 3 over 6, which is drawing red, plus 1 over 6, drawing yellow first again, but this time drawing blue. All right? Seems like a lot of work, but if you multiply that all out, you end up getting 11 over 18. So that is drawing with replacement, if replacement occurs. All right? And making sure that you have the pairs. So my red coming first should happen twice because I have 3 different events. Then my blue. All right, so noticing that I have my red and my red.